Okay, so we're going to look at a question 6 from 2019 that involved confidence intervals. Now, this is not a standard confidence interval. Matter of fact, question 6s are investigative tasks, and a lot of times they will introduce something new and want to see what you can come up with. So in 2019, you can get up to 4 points on a question 6. The average score was 0.99, so less than 1 point. So just under 1 point out of the 4 points was earned, and that was basically the sample mean, 0.9, just under 1. So let's take a look at this, and this is going to be, like I said, it's going to be different than what you learn in class. So Emma is moving to a large city and is investigating typical monthly rental incomes available for 1-bedroom apartments. So this is what she's interested in. She obtained a random sample, that's good, of rental prices for 50. So here's our sample size. 51 bedroom apartments taken from a website where people voluntarily list available apartments. Describe the population for which it's appropriate for Emma to generalize the results. So this is going back, okay, we've collected this data, this sample, what population can we generalize to? Well, you can only generalize to the population that matches your sample. So we can generalize to 1-bedroom apartments taken from the website. You needed to have both of those elements. Because a random sample was taken, and by the way, we have to address the fact that we took a random sample because that's why we can generalize it. Without that, we're kind of limited. We shouldn't be doing it. So Emma's results can be generalized to 1-bedroom apartment rental prices listed on the website. So I needed to actually address all 3 of those things. All right, so that's part A of this. And then basically to get our first, and that won't get you a point yet. That's helpful, but that won't get you the full point. Then we go to part B, and it says the distribution of the 50 rental prices available is shown in the following histogram. And if I'm just looking at that histogram, I'm kind of looking at it and go, you know what, this shape appears to be skewed to the right, which means my mean is going to be above my median. All right, so maybe my median occurs here and my mean is somewhere over here because the high values are pulling it up. Don't forget that. So Emma wants to estimate the typical rental price of a 1-bedroom apartment in the city based on the distribution. What is a disadvantage of using the mean rather than the median as an estimate of the rental price? Well, basically, the mean is going to be impacted by extreme values and the median is not. So because the distribution of rental prices is not symmetric and is skewed to the right, the mean will tend to overestimate typical rental prices. And that's what's going to happen. The mean is going to pull it up, all right? Pull up the typical rental price due to a few prices being higher than what is normal. The median is not impacted by extreme values and would provide a more accurate representation. So notice I addressed the shape, the mean, and the median. So I had parts A and B together would get me 1 point. So I needed to make sure in part A that I said that it was a 1-bedroom apartment from a random sample and that it came from the website. Part B, I had to say that it was skewed to the right and the mean will overestimate and the median is not impacted by extreme values. If I had all of those components for A and B, I get 1 point. Part C, instead of using the sample median as the point estimate for the population median, Emma wants to use an interval estimate, okay? Once again, a range of values. However, computing an interval estimate requires knowing the sampling distribution of the sample median for samples of size 50. Emma has 1 point because she only took 1 sample. She took 1 point, she has 1 sample, she has 1 median. in that sampling distribution, using information about rental prices that are available on the website, describe how someone could develop a theoretical sampling distribution of the sample median. Well, we've never talked about that. It's not part of the course. We've never talked about a theoretical sampling distribution of the sample median. We have talked about the theoretical sampling distribution of the sample mean. So the theoretical distribution for the sample mean is that we take all possible combinations of size 50, and that will describe the theoretical sampling distribution. In other words, we did it over and over again until we got all possible combinations. Well, for the sample median, it's the same thing. You would need to collect all possible combinations, and this is important because they ask for the theoretical. So the theoretical is based on all possible of samples of size 50 for one-bedroom apartments listed on the website, and compute the median for each one of the samples. All right, this part C was worth 1 point. And basically we need to say that, hey, we have, if you only mention the 50 one-bedroom apartments, you only got part. The median samples of size 50 for one-bedroom apartments, that only got you part. And if you didn't use all possible combinations, you had to have all possible combinations as well. Those two things had to be there in order to get that full point. It's a long problem. Because Emma does not have resources to develop the theoretical sampling distribution, she estimates the sampling distribution of the sample median using a process called bootstrapping. Once again, this is not something we teach in introductory statistics. It's not part of AP statistics, so this is new, never seen it before. My wife actually uses it at her work because she models distributions for catastrophic events. So it's done quite frequently in the business world, but it's not part of this course. It's going to be at the next level. So in the bootstrapping process, a computer program performs the following steps. So they're actually telling you what to do because they know you haven't been taught this. So take a random sample. Notice most of the time we take a sample, we do it without replacement, but here we're going to do it with replacement of size 50 from the original sample. Calculate and record the median of the sample. So we're going to take a sample of size 50 and we're going to do this over and over and over again. We're going to do this 50,000 times. So once again, our sample size 50, and for the number of times we're going to do this is 15,000 times. So Emma ran the bootstrap process, and the following frequency table is the bootstrap distribution showing her results generated. So it's got this long table, all right? And rarely would you ever have to input the data into the calculator. And this is one of those times that you can kind of avoid it. So the bootstrap distribution provides an approximation of the sampling distribution of the sample median. A confidence interval for the median can be constructed using a percentage of the values in the middle of the bootstrap. So they're saying, ooh, there's that word confidence interval. So this is how this relates to confidence intervals. And it says, part D has 2 parts. Use the frequency table to find the following: the value of the 5th percentile and the value of the 95th percentile. Well, remember, percentiles work going from left to right. So in this case, the very first thing I want to do is find the 5th percentile. And while this is a little bit tedious, this definitely can be done. We can go, all right, take your calculator. And first off, we go, you know what? I should slide this up. We went 5% of 15,000. So this will be at the frequency of 750. So we're looking at the frequency of 750. So I'm going to take and go, you know what? That's a frequency of 1 plus the frequency of 13. Well, that's not 750. Plus 18, still not there. Plus 56, plus 4, plus 56, plus 55, plus 3, still not there. Plus 66, not there. Plus 136, not there. Plus 1899. Hey, we just crossed over. So one of those values in this 1899 is my 5th percentile. So this is where my 5th percentile occurs. All right. So my 5th percentile occurs at $2,500. All right, because these are median prices. So the 5th percentile occurs at $2,500. The next thing it asks for is a 95th percentile. So 0.95 times 1,500, and I can keep adding all the way up. I can keep adding all these all the way up, and I'm going to ultimately end up here. Now, instead of adding all of these together, what I would suggest is that we work backwards. And basically, that's going to be this 15,000 minus the 5%. And that gives me at 14,250. All right. That's what we're looking for. But basically, this right here, if we're working backwards, I need to come up with 750 working backwards. So doing that, 3 plus 2 plus 6, enter, plus 1, enter, plus 12, enter, plus 65, plus 6. We're still not there, but as soon as I add that 700, we're there. Because we needed 750. All right. So our 95th percentile occurs at 2,950. So these are basically, we're basically saying, all right, this is my low point, and this is my upper point, 2,500 to 2,950. Unfortunately, I can't fit this on the next page, but this is the same table. And it says, the Bootstrap distribution provides an approximation of the sampling distribution, et cetera. And then it says, find the percentage of Bootstrap medians in the table that are equal to, notice it says equal to, or between the values found in part D. So essentially, I'm adding up 8, and it says equal to, so that means including 1899 and including 2950. And essentially, I'm adding up all these values. Okay, I'm adding up all these values in between. And when I do that, I end up getting 14,404 divided by 15,000, so 96%. So about 96% are between 2,500 and 2,950. And you're like, where did the 2,500 come from? That was my 5th percentile. My 95th percentile was at 2,950. That's what we calculated in part E. All right. So now we have a lower bound and an upper bound, and part D and E, part D and E together go together to get you 1 point. Part D and E go together to get you 1 point. Part F, use the values from part D and E to construct and interpret a confidence interval for the median rental price. Well, basically, that's what I'm showing right here. And what are we? Well, we're 96% confident. We are 96% confident the true population median price of 1-bedroom apartments advertised on the website lies within the interval 2,500 to 2,950. Notice this follows the same recipe that we use when we're writing conclusions. The only thing is we're not working with the mean, we are working with the median. You had to have median in order to get full credit, and part F was also 1 point. Now, some people may have said, you know what? This was the 5th and the 95th percentile. The difference between those happens to be 90%. If you did that and you said, you know what? We are 90% confident that the true population median lies within this interval, they gave you full credit. They wanted the 96%, but because the 5th and 95th actually gives you 90, they gave you full credit for either 90% or 96%. And if you had 90%, you could get a full point. If you had 96%, you could get a full point. If these values happen to be wrong, but matched what you calculated in part D, you could still get full credit. So make sure you don't give up, all right, that you get what you can. Because even if you messed up here, you can still get points over here, all right? And remember, the kind of the goal is we would be thrilled if we could get you 2 points on question 6. If you're getting 2 points on question 6, you're probably well on your way to getting a 5. And we definitely want you to get 1 point. And we can sit there and go, you know what, the average score was under 1 point. So if you're doing that, you're doing pretty well on this. So thank you. Hope that helped.